think you meant to say how many numbers are there? Yeah. Or how many, right? So to do this, you would do, so you've done this many times before, like a average is going to be the sum of all of the elements divided by 6, which is the number of elements. And that would be the average of those things. We good with that? So let's generalize it a little bit more. So we can figure out, I'm not actually interested, you don't have to do the answer to that, but do you understand where that comes from? Yes, okay. Suppose you go 100 miles in 2 hours. How do you figure out your average velocity? If you go 100 miles in 2 hours, how would you find your average velocity? What would you do? What would you do, Mark? I can't hear you.
Total distance divided by total time.
Yeah, and that comes from distance equals rate times time, right? So effectively you're finding your rate, which is going to be distance over what? So in this case, it would be 100 miles divided by 2, so that would be 50. So is that another average? Absolutely. So this is the total distance traveled, that would, let's say, points scored, and then you're dividing by the time it took you to do that, or the number of people, or like number of games the person played. So it's the same idea. It's the exact same idea. Now here's the thing. Can you find the average of 3 numbers? Sure. 5 numbers? Absolutely. How many numbers could you theoretically find the average of, given enough time? As many as you want, right? An arbitrary number, right? And that's effectively what we're going to be doing here. So let's say we did this. This is the question we're going to be targeting here in terms of what we need to learn. Given velocity is equal to that function, so that is v of t is equal to t squared plus 1. Find your average velocity from time equals 0 to time equals 5. Find the average velocity from time equals 0 to time equals 5. So up here, how is that question different than number 2? What are they giving you directly on number 2? They're giving you 100 miles in 2 hours. They're giving you directly one of those things on this question right here. What's the one thing they're giving you that's very similar? Time. So effectively, what's the total time on this one? What is it?
5.
Yeah, exactly. Equals 5 minus 0 is 5. Could this question be asking that time equals 1 to 6? Sure, that would still be 5. The idea is you have to subtract b minus a, right? You've done b minus a many times. It's like the base. What do they not give you directly, though? How is it different than what's up here? What do they give you up here directly that they don't give you down here directly? What do they give you in this question directly that they don't give you here directly? The distance traveled, right? The distance traveled. So you don't know the distance traveled. If you had the distance traveled and asked for the velocity and gave you time, what do? Just like this question, what do you divide? You divide distance traveled by time, and what do you get? Velocity. What do you have down here? Well, you have the time. What do you need? What do you need to figure out? The distance traveled. Are you with me so far? Lindsay, how do we find the distance traveled?
Distance equals rate times time.
True, but we now have a velocity function.
Would you just like plug each number in from 0 to 5?
So you could, I actually really like that idea. That would be analogous to the first one, right? So you could do like v of 1 plus v of 2 plus v of 3 plus v of 4 plus v of 5, right? And then divide by 5. I like that idea. Would that be an exact answer? That would be the velocity at time equals like 1 hour, and the velocity at 2 hours, the velocity at 3 hours. That wouldn't be exact. That would be a what? An estimate, right? How would you make the estimate better? How would you make the estimate better? More data points. So instead of dividing by 5 with 5 data points, how many data points could we have?
10.
Yeah, you could have like v of 1.5, right? Plus, and then v of what? 2.5, right? You could add in all of the midpoint ones, like v of 3.5, v of 4.5. That would be adding in 4, so I divide by 9, right? Would that be exact yet? No. You would want to theoretically add up how many things? You'd want to, how many samples do you want in order to make it perfect? A highest you want to approach infinity, right? So that's the same as adding up how many rectangles. So what are we doing here? We're adding up a lot of rectangles. We want to add up effectively all the rectangles when we divide it into an infinite number of pieces. You learned how to do that yesterday on your calculator. What am I asking you to actually do? The distance traveled is, so if this is the velocity graph, this velocity graph is going to do something, right? I'm just making this up. What, a t squared plus 1 is going to look something like this, right? There's your velocity graph. Where is the distance traveled on that picture? Where is the distance traveled on that picture? It's there somewhere. Where is it? It's the area from what? 0 to what? To 5, right? How do you find the exact area from 0 to 5? What do? You take the, what's it called? The Riemann sum, yeah, but we want to call it a what? What's that symbol called? The integral from 0 to 5 of v of t dt. Do you know how to do that on your calculator now? Yeah, we can make an estimate of this. You've done estimates a bunch on these, right? You could do the left-hand estimate, the right-hand estimate, make the average. You could do the midpoint, right? Those are all estimates. But now, do you have a way of doing this exactly? Yes. So do you remember what you type into your calculator? So let's say y1. You make y1 equal to, what's the function? Was it t squared plus 1?
Yeah.
So on your calculator, since it likes to keep things in x, it would be y1 is equal to what? X squared plus 1? And what would this be on your calculator? It would be fn int. You learned this, yes, or Friday. Fn int of what? What goes first?
Oh, she showed us.
Yeah, what is it? Do you remember what?
Y1.
y1, comma what? X, comma, what are the next two numbers? Do you remember? They're right there on the board. 0, 5. Everybody do this on your calculator right now and tell me what it is. So on your calculator, some of you are gonna, it's actually gonna be like blanks, right? So what do you plug in? You plug in 0, 5, y1 and make it dx, right? So it's called true type or math type on your calculator. There was an operating system upgrade that happened. Math print, thank you. There was an operating system upgrade that happened a few years ago, and many of the calculators now have it. Almost all, but not all do. If you have an older calculator or one that hasn't been upgraded, that's what it'll look like. Otherwise, you plug it in like this. Either way, you should get the same answer. And by the way, you can turn math print on and off, by the way, if you don't like it or you want it on some of the calculators. So anybody have the decimal for this?
46.67.
What'd you get?
46.67.
46.67. Anybody else get that same thing? 46.67. So that is what? What does that 46.67 represent? What is this? The distance traveled from 0 to 5. Right. Does it give us units on this? Yeah, feet, right? So feet traveled from 0 to 5 seconds. So if we want to know what the average velocity is, we're going to do 46.67 divided by what? 5. And what do you get? What do you get? 9 point what? So 9 and a third? Yeah. So you could say 28 thirds. Sure. 28 thirds. Question for you. Let's say I went 100 miles that way, and then I went 100 miles back, coming back to exactly where I started. What was my velocity? What was my average velocity over that time period? If I end up exactly where I started, what was my average velocity? Doing when you're finding average velocity is you're finding the height of the box that would result in the same area as you get when you integrate under the curve. Does that kind of make sense, everybody? That's all you're doing here, because distance under the curve is going to be the displacement. You want to have the same displacement. You're just finding a box that represents the same displacement as a curvy thing. The magical thing, not magical, you know where it comes from, the thing that allows you to do this exactly, because your calculator's still rounding, by the way. 46.67, what is that? That's really 46 and 2/3. Like when you see 667, that's almost always going to mean it's rounding a little bit there. And generally when you can, how many decimal places do I want? I want 3 when you can. So you find displacement, you divide it by how much is time that's gone by. The general formula you're looking at, I think it's down here, is right here. This is what we did. We just did this. In this case, in our equation that we just did, the velocity function was what? It was x squared plus 1, right? What was our b value? 5. And what was our a value? 0. All we did was plug into there, because what does this represent? That represents the 5 hours that has gone by, right? What does this integral represent? This represents the displacement. So what did we do? We divided displacement by time that has passed in order to get average velocity. Can average velocity be negative? Sure, you could be going backwards.
We did displacement divided by b minus a.
That's what we did. This is just, yeah, this statement is displacement divided by b minus a, because 1 over b minus a, multiplying by 1 over b minus a is the same thing as dividing by b minus a. Exactly. So you can do other ones like this. So this is what it looks like graphically. Here's a little better drawing for what I just did there. We just did this, right? We added up all of these infinitesimally small rectangles, and we got a certain area right here, correct? See that right there? But what did we find? Well, if you just took a box that's 9 1/3 high, that area right there, the whole area, is the same as the area under the curve from there. That's what we did. That's all we flattened it out. That tells you the area right there. Look, base of the rectangle, head of the rectangle. That's all we did. So you can apply this to things other than average values, and you sometimes don't need an integral. sorry, things other than velocities, area is 9, right? So if you wanted the average value, you divide 9 by what? If you want the average value, take a look at the function. What are you going to divide 9 by in order to get the average value? What? 4, exactly, because you go from 0 to what? 4. So the average value is going to be 9 over what? 4. So that's roughly 2 1/4, or a little bit higher than that, right? 2 1/4, right there. So if I draw this over here and go straight down, what do I know about this red right here? Well, it's 9, exactly. 9 over 4 times 4 is 9. So we just found the height of the rectangle that has the same base as the original shape, but it has the same area. That's all we're doing on this. That's all we're doing. So don't forget basic geometry. Don't forget basic geometry.